Step into the world of weather with World Weather Authority, your number one source for all things meteorological. Covering every corner of the globe, we're dedicated to delivering you the most accurate, timely, and comprehensive forecasts, ensuring you're always prepared, whatever the weather. Our experienced team of meteorologists are at the forefront of weather technology, tracking patterns from the serene to the extreme. Here at World Weather Authority, we go beyond the forecast, delving into the science behind the weather and its impact on our environment, our lives, and our future. Our commitment to accuracy and insight has built a community of viewers who trust us for their weather news, fascinating facts, and crucial updates. So why not join us? Don't miss a forecast. Subscribe, hit that bell icon for notifications, and follow us on social media. Stay ahead of the weather, no matter where you are, no matter the season. This is World Weather Authority, where the weather is always the news.
Good evening, everyone. I hope this message finds you well. This is Chief Meteorologist Zach Clark with World Weather Authority. I trust you all are having a lovely evening. We have a plethora to discuss concerning tropical weather developments, so let's dive right in. To all my fellow Floridians out there, I have good news for you. It appears that you will finally experience a break from the significant rainfall that has recently inundated the region. Many areas have received nearly 2 feet of rain from the latest weather system. I hope you all are in good spirits and that the cleanup process proceeds smoothly and effectively. Unfortunately, here at World Weather Authority Studio, we are closely monitoring the Bay of Campeche for a developing system. A broad area of low pressure is projected to form over the southwestern Gulf of Mexico late this weekend or early next week. Current environmental conditions appear favorable for the gradual development of the system, with the potential for a tropical depression to form by early to mid next week as it moves slowly westward or west-northwestward. We can see the next 2 days, there's a 0% chance of development. However, over the next 7 days, we have a 50% chance of development. Overall, we have a medium concern of this system, definitely approaching the high concern as well. So we're going to have to keep our eyes on this system. The process will begin with a pre-existing weather disturbance. This could be a tropical wave, a frontal boundary, or remnants of an old frontal system. In our case, though, a broad area of low pressure is forecast to form over the southwestern Gulf of Mexico. For a tropical system to develop, sea surface temperatures need to be sufficiently warm, typically above 80 degrees Fahrenheit. The Bay of Campeche generally maintains these warm temperatures, providing the necessary heat and moisture to fuel the developing system. In the region of development, the sea surface temperatures already exceeding 80 degrees Fahrenheit, ranging from 82 degrees all the way up to 86 and 87 degrees. So it's definitely very warm in the Bay of Campeche. Unfortunately, where this storm system is projected to traverse. Adequate moisture in the mid-troposphere, approximately 3 to 5 kilometers above the surface, is crucial. Dry air can inhibit the development of thunderstorms, which are the building blocks of tropical cyclones. The current environmental conditions appear to be conducive for maintaining sufficient moisture levels. Taking a look at the tropical cyclone formation and intensification, with the vertical wind shear here. Wind shear refers to the change in wind speed and direction with height. Low vertical wind shear allows the system to organize and strengthen by preventing the tilting and dispersal of the storm's warm core structure. The forecast indicates favorable wind shear conditions in the southwestern Gulf of Mexico, which supports the system's development. So right in this region here, you guys can see that white arrow pointing to this region here, the Bay of Campeche. We can see the green lines and the yellow line there as favorable and neutral conditions. Low vertical wind shear is a critical factor in the development and intensification of hurricanes. Vertical wind shear refers to the change in wind speed and direction with height in the atmosphere. Specifically, it is the difference between the winds at the surface and those at higher altitudes, typically measured between the surface and the upper troposphere, which is around 200 to 300 millibars. Low vertical wind shear allows the developing hurricane to maintain its vertical alignment. Hurricanes are vertically stacked systems with a warm core that extends from the surface to the upper levels of the atmosphere. When this vertical wind shear that we talked about is low, the storm structure remains coherent and the circulation is not tilted. This alignment is essential for the efficient organization of thunderstorms around the storm center, which strengthens the cyclone. Hurricanes rely on symmetrical convection around their center. Low wind shear ensures that the convection or the vertical transport of heat and moisture remains concentrated near the storm's core. High wind shear, on the other hand, displaces this convection away from the center, disrupting the storm's ability to intensify and sometimes leading to its dissipation. Hurricanes operate as heat engines, extracting energy from warm ocean waters and converting it into kinetic energy. For this process to be efficient, the storm needs to maintain a strong updraft at its core. Low vertical wind shear allows for the continuous updrafts and downdrafts necessary to sustain this heat engine process. High wind shear disrupts this balance by tilting the storm and spreading out the core's convection, reducing the efficiency of this energy transfer. During the early stages of development, tropical disturbances require a stable environment to organize into a tropical depression, tropical storm, and eventually a hurricane. Low vertical wind shear provides a calm atmospheric environment that allows the disturbance to concentrate its energy and moisture into a well-defined center of circulation. This conducive environment is particularly crucial for the rapid intensification phases where storms can strengthen quickly if other conditions, such as sea surface temperatures and humidity, are also favorable. All right, folks, this might be a lot, and for the more astute folks, from a mathematical perspective, the dynamics of hurricane formation can be modeled using equations of fluid dynamics and thermodynamics. The Navier-Stokes equations, which describe the motion of viscous fluid substances, are particularly relevant. In a low shear environment, the terms that represent vertical advection and horizontal shear are minimized, allowing for a more axisymmetric solution, which is stable and supports cyclonic development. I'll leave this on the screen just for a few seconds for you guys to see. So you can see U here is the velocity field of the fluid with components U, V, and W representing the velocity in the X, Y, and Z directions respectively. T is time. P is the pressure field. This term here is the kinematic viscosity, and F, it represents external forces such as gravity or the Coriolis force. We have the radial momentum equation. We also have the azimuthal momentum equation and the axial momentum equation. And of course, we always have to have the continuity equation for incompressibility condition. So like I said, I'll leave that up there. It's a lot to digest. There's a lot of differential equations, partial differential equations, a lot of calculus involved. But these equations are very important in hurricane forecasting and dynamics. So yeah, it's definitely interesting. The things I deal with on a daily basis, especially recently as hurricane season has erupted. So we'll see what goes on, folks. Maybe I'll include a video on how to utilize these equations if you guys are interested in that. Historical data and statistical models support the importance of low vertical wind shear. Observations show that most intense hurricanes develop in regions where vertical wind shear is below 10 meters per second, or about 20 knots. The correlation between low shear and hurricane intensity is well documented, reinforcing the theoretical understanding of the physical processes involved. The top image there is no vertical wind shear. You can see this system is vertically stacked. It definitely has, it's very symmetric here. Definitely looking like it has very, very good structure. This is what you would want to see in a hurricane. Obviously, if you're tracking a hurricane and you like to see the intensity on satellite data observations, unfortunately, if something like this is heading your way, it's definitely not good news. The bottom image shows or depicts the same hurricane with vertical wind shear added. So it tilts the system, eventually weakening the system since the system is not symmetrical anymore. Unfortunately, it will be tilted, and the system will most likely rapidly deteriorate. So it's definitely pretty interesting. It's definitely an interesting process with vertical wind shear. Definitely hope that is an interesting topic for you guys. I also want to include some derivations of vertical wind shear in another video as well, so definitely stay tuned for that. All right, now back to the system that we are looking at in the Bay of Campeche. So according to one of our computer models, the Global Forecast System, or the GFS, we observe pressure anomalies across the Bay of Campeche extending towards the Cabo Rojo region of Mexico. The model indicates that the system's central pressure could drop to approximately 999 millibars by the end of the forecast period. This pressure level suggests the development of a storm system with winds ranging from 50 to 55 miles per hour, indicating the potential for it to become a tropical depression or tropical storm upon landfall. A tropical depression is a tropical cyclone with maximum sustained winds less than 39 miles per hour. So we're probably going to look at a tropical storm here impacting the Cabo Rojo region of Mexico. So it's characterized by a defined circulation and organized convection, but lacks the intensity to be classified as a tropical storm. Unfortunately, here it looks like we will be dealing with a tropical storm. So a tropical storm, on the other hand, has maximum sustained winds ranging from 39 miles per hour to 73 miles per hour. If you want that in knots, that's about 34 to 63 knots. Both systems can bring significant weather impacts, including heavy rainfall, gusty winds, and potential flooding. And in the case of the Cabo Rojo region of Mexico, a tropical depression or tropical storm can indeed bring intense rainfall. The heavy rainfall associated with these systems can lead to flash flooding and river flooding, especially in areas with poor drainage or already saturated soil. The convective activity within these systems can produce prolonged periods of heavy rain, exacerbating flooding risk as well. The terrain of the Cabo Rojo and surrounding areas can amplify these impacts. Coastal and inland regions with varied topography can also influence the distribution and intensity of rainfall. Mountains and hills can enhance orographic lift, where moist air is forced to ascend the terrain, cooling and condensing to form clouds and precipitation. This process can result in localized areas of extremely heavy rainfall, increasing the risk of flash floods and landslides. Moreover, the interaction between a tropical storm and depression and the mountainous terrain can lead to additional hazards. The terrain can disrupt the circulation of the storm, causing it to weaken more rapidly than it would over flat land or open water. However, the enhanced rainfall from orographic lift can still pose significant threats. For the Cabo Rojo region, preparedness and monitoring are crucial. Residents should be aware of the potential for intense rainfall and flooding, particularly in areas prone to these hazards. Meteorological agencies will continue to provide updates, along with World Weather Authority here, and forecast to ensure that the local population is informed and can take appropriate action to mitigate the impacts of these tropical systems. Let's let that play a little bit there. You can see that the circulation there gets very well defined at the end of that loop there, right before it impacts the Cabo Rojo area there. So we're going to have to watch this. This could definitely be an interesting system. We continue to monitor Invest 90L. This is an area of low pressure located offshore of the southeastern U.S. So it looks like it's right offshore of, let's say, North Carolina there. And unfortunately, it is generating disorganized shower and thunderstorm activity. However, the system is unlikely to acquire tropical characteristics due to strong upper-level winds. As it moves northeastward over the western Atlantic, it is expected to merge with a frontal system on Saturday, which is tomorrow. Current model guidance indicates that this system will remain offshore and is not expected to impact the United States directly. However, one of the models does suggest that the storm could pass over Newfoundland between Locks Cove and Richards Harbor. Beyond this potential interaction, the system is forecast to move out to sea. Nevertheless, we should remain vigilant for high surf and rip currents along the eastern seaboard of the United States, as these hazardous conditions could affect coastal areas. You can see that track there, and you can see that one little outlier coming up through Newfoundland there. As I said, that's between Locks Cove and Richards Harbor. Nevertheless, it does look like this storm is expected to remain out to sea. So we're going to have to keep an eye out on this. We'll see what happens. Maybe it will jut back towards land here and impact Newfoundland, which would be would definitely bring some high winds, some high surf, flash flooding potential, various things like that. So we'll keep an eye on it here at World Weather Authority Studio. All right, ladies and gentlemen, this is where we get into the interesting aspect. This is the official NOAA CPC ENSO probabilities. This was issued June 2024, so this was issued this month. This was actually updated yesterday, 13th of June 2024. So this is a notable climatological shift. El Nino conditions have concluded and La Nina is commencing. Currently, we are in a neutral phase, but increased attention should be directed towards the Bay of Campeche here, folks. The transition from El Nino to La Nina necessitates heightened vigilance over the Atlantic for hurricane activity, particularly in the Caribbean and the Gulf of Mexico. During the preceding El Nino phase, prevailing wind patterns directed many storm systems up into the Atlantic, often causing them to loop away from the United States. This pattern is now changing as reduced upper-level wind shear fosters an environment more conducive to storm formation and intensification. The transition between El Nino and La Nina has profound implications for hurricane development in the Atlantic Ocean. So we're going to have to watch this. So right at the bottom here, you can see the percent chance. Looks like we're almost at 100% chance for the neutral phase. This is for May, June, and July. That's what MJJ stands for. As we head into June, July, and August here, we're definitely looking at the percentages coming down. So 60% neutral phase, about 40% for La Nina. And then as we head into July, August, and September, we're looking at basically a full-on La Nina event here. And then as we head into August, September, and October, July, August, and September, and then August, September, October, in this region here, folks, is when we see the most enhanced tropical activity. And unfortunately, it looks like we're going to be in a full-fledged La Nina event. So it's definitely going to be very interesting as we head forward. We're going to have to keep an eye out. This can definitely be an extremely historic 2024 hurricane season. It's going to be profound, folks. Very prolific in terms of hurricane activity. Historical data over the past 30 years indicates that there have been about 45 major hurricanes during El Nino periods, in contrast to 105 major hurricanes during La Nina periods. You can see on the right there, El Nino hurricanes in the last 30 years. And then on the left there, unfortunately, that's the big player, folks. That's La Nina hurricanes in the last 30 years. 45 hurricanes versus 105. That represents an increase of 133%. This is a substantial rise in activity suggests that we may be on the verge of a potentially historic hurricane season. The current high-pressure system above the Cabo Verde Islands will continue to exert a significant influence on storm development. Many systems are likely to form south of this high-pressure area, increasing the probability of their entry into the Caribbean, possibly even into the Gulf of Mexico. So if you live on the Gulf Coast in the Caribbean, definitely be on the lookout, even down through Cancun, Jamaica, Cuba, Dominican Republic. We're going to have to watch out, and even down through Haiti as well. We are going to have to keep an eye out for major hurricane activity coming in. Like I said, this is an increase of 133%. So from last season to this season, it's definitely going to be very historic. Just to give you guys perspective, those are the Cabo Verde or the Cape Verde Islands. Tropical waves, also known as easterly waves, are atmospheric troughs that move westward from the African coast into the Atlantic Ocean. These waves are crucial precursors to many tropical cyclones, particularly during the Atlantic hurricane season. The dynamics of these waves and their potential paths are significantly influenced by the broader climatic conditions, such as the transition from El Nino to La Nina, which we are experiencing, and their formation relative to the Cape Verde Islands. We're definitely going to have to monitor some of these waves closely. There's actually 2 waves coming off the African coast. We're definitely going to watch those as they come off, and we'll see if those stay together or if they hold together and actually come up to impact the United States. Unfortunately, we are anticipating the potential development of another disturbance from Friday, June 21st through Sunday, June 23rd. This system appears to be targeting the Florida Panhandle, particularly near Apalachee Bay. So definitely please stay tuned for further development. It's definitely going to be very interesting. Looks like it gets down to 999 millibar. This could be a tropical storm there. So definitely be on the lookout, folks. Again, folks, in conclusion, the key takeaway is the transition from El Nino to La Nina. Preparation should be made as usual, but it is essential to be aware that the patterns seen over the past 2 hurricane seasons may not continue. The likelihood of increased hurricane activity necessitates heightened readiness. Stay informed with updates from World Weather Authority to ensure preparedness for the forthcoming season. Stay safe and stay vigilant. And if you are enjoying our content, please consider hitting the like button, subscribing to our channel to ensure you do not miss future updates, and sharing this information with those that need it the most. Thank you, and always remember, dominate the storm.
From the scorching deserts to the icy poles, the world's weather is a diverse and captivating symphony. At World Weather Authority, we're the maestro conducting this grand orchestra of meteorological data. Imagine the gentle rustle of the wind, the pitter-patter of the rain, the roar of the ocean's storm. We translate these atmospheric tales, painting a picture of our planet's ever-changing climate. Our dedicated team, the heart and soul of World Weather Authority, tirelessly deciphers these complex codes. Our mission is not merely predicting tomorrow's weather, but to arm you with the understanding to dominate the storm. The trust you place in us, your engagement, stokes our passion for meteorology. It drives us to provide you with the most comprehensive, accurate weather coverage. So from all of us at World Weather Authority, our gratitude for your continuous support. Stay safe, stay informed, and remember, together we can dominate the storm. As the music fades and the curtain closes, we bid you farewell until next time. Remember, the world's weather is always in motion, and so are we, ready to guide you through it. To ensure you do not miss any future videos, subscribe to the channel and enable notifications. Thank you.